These last two sections are also about equilibrium, and they're specifically going to be talking about something called Le Chatelier's principle. And Le Chatelier's principle basically states that if you disturb a system, it's going to react in a direction that will counteract that disturbance. So if you disturb the system that's at equilibrium, all right, so it's K equals 1 and it's going back this way and back that way and it's all happy. And then you do something to disturb it, or also called stress it, then it's going to react in a way that's going to counteract that or relieves the stress. So ways you can disturb an equilibrium reaction is change the concentration, change the temperature, or if they're gases, change the pressure. So I have a gas reaction here, and it's at equilibrium. And what happens if I add more CO? Okay, so I'm going to add some CO, which is right here. And so by adding CO, what I'm doing is I'm pushing the system on the reactant side, which is going to push it towards the right. What will happen is this will decrease, and the other reactant must also decrease if one of them does. And so that means that it will increase the concentration of the CO2 because I made this reaction go to the right. So by adding more CO, I pushed this reaction to the right, which made the other reactant go down and increased the product. What if I add more product? If I add CO2, this time what I've done is I've pushed on the product side, which is going to make it go to the left. It's going to decrease this, right? Because I'm trying to undo what I did. So if I added product, this is going to have to decrease product to come back to the state of equilibrium. It's going to push this way, and so it's going to increase the concentration of the CO and the O2. What if I remove product? So in this case, when I remove something, I think of it as pulling. So when I'm adding something, I'm pushing on whatever side I am adding it to. When I remove something, I'm pulling it with it. So if I'm removing, water is a product here. So if I'm removing water, I am pulling it to the right. So that means if I pull it to the right, I'm going to make more product here, right? Because I'm having to remake product to reestablish equilibrium, which means what has to happen to the reactant? It has to what? Decrease. So when I remove something, I pull it out. So I pull it in that direction, and so everything, this goes down because I'm pulling, and this will have to go up because I made that reaction move to the right and make more product. When the temperature is increased, the reaction that absorbs the heat is favored. So just think about which side, wherever you're adding heat, think of it the same as if you were adding concentration or anything else, okay? So if you're increasing temperature, you're adding heat, all right? Now, if it's an endothermic reaction, that means you're adding to the system. So that means that in an endothermic reaction, your heat was over here, okay? Your heat, which is being added already, is a reactant, okay? So if you add more heat, what that's going to do is it's going to then push that to the right. So an endothermic reaction that absorbs that heat is going to increase the temperature, and it's going to push that reaction in the forward direction or to the right. So if you see a positive delta H, that is a reactant because you are adding that to the reactants. You're adding heat in order, or energy, in order to make the reactant go. So since it's a reactant, you're adding reactant by increasing temperature and adding heat. So that's pushing it this way. What if you increase the temperature on the product side in an exothermic? If it's exothermic, you are releasing heat. So if you're getting rid of heat, that's the same thing as writing plus 22 kilocalories, okay, on the product side. So if it's a negative enthalpy, negative 22, that's the same thing as saying, oh, that's a product, so the product is 22 kilocalories. And so if I add temperature to this side that I already had the 22 kilocalories on, it's going to drive it to the left. So in the exothermic, if you increase the temperature, it's going to favor the reverse reaction. If you decrease the temperature, though, what would it do? That would be like, if you decrease the temperature, that would be like pulling it, like when we were removing water or removing a product. And so that's then going to make it go in whatever direction you're removing. So if I'm removing it from the product side in an exothermic reaction, that means it's now going to favor the right side or the product. Pressure changes really only affect gases. So all of your components are typically gases when you're looking at pressure. When you increase pressure, this one's a little different. The equilibrium shifts in the direction that decreases the number of moles, okay, because you're trying to decrease the pressure. So if you have, so what I'm saying is, if you look here, you've got 1 nitrogen and 3 hydrogen, so you've got a total of 4 moles. On your product side, you only have 2 moles, so that's fewer moles, okay? So if you increase pressure, then you're going to go towards the one with fewer moles because you want to decrease these when you increase pressure. So the rule basically is this: if you increase pressure, then the direction is going to be towards the fewest number of gas moles. So since this one had 2 and this one had 4 and we're increasing pressure, it's going to go towards the one with the 2 moles and away from the 4. If you decrease the pressure, it's going to go towards the side with the most moles. So if I decrease pressure over here, that the 2 moles and the 4 moles, then it's going to go towards the side with the most number of moles. It's just kind of something you almost have to memorize to answer a question. So I have a summary for Le Chatelier. If you add reactant, then it's going to go, you're going to push it to the right. If you remove reactant, you're going to, what, pull it to the left towards the reactants. If you add product, then you're pushing it towards the reactants. And if you remove product, then you're pulling it away and out towards the products. Increasing the temperature in an endothermic is going to push it towards the reactants. In an exothermic, towards, products, my bad. Increasing temperature in endothermic is going to favor products. And increasing temperature in exothermic is going to favor reactants. And then, of course, decreasing temperature is the opposite, so just learn one of them. Increasing pressure is going to go towards the fewer moles, okay, so whichever one is fewer. So it's not always a left or right thing. It's the least moles. Now here's another area where you could just memorize half of this. All right, so if you add reactant, if you add reactant to if you add a reactant to the reaction, it's going to favor the products. So if you know that, then you know that removing it is going to be the opposite. If you add product, it's going to push it back to the reactants, and so you know if you remove product, it's going to do the opposite. With temperature, learn what happens in an endo and exo when you increase the temperature, and you'll know automatically if you decrease the temperature, it's the opposite. And then finally, increasing pressure, it's going to favor the side with the fewest number of moles, and so you know decreasing pressure is the opposite. So instead of having to memorize all of these, you memorize half of them. And so one of the ways that Le Chatelier is implemented in the body is in the brain you have an organelle called the hypothalamus. Okay, and so the hypothalamus is like the temperature controller. So that's what acclimates you to hot weather. That's what tells you you're hot or you're cold or whatever. So in the hypothalamus here, when you start to feel hot, then it is going to send a signal to your sweat glands, and they're going to stimulate those, and so that you sweat, and so that you're going to evaporate, and then that is going to cause you to cool down. Okay, it'll also cause your blood vessels to dilate and release heat and constrict to less temperature changes. And so in body temperature, what you're doing is you're creating an equilibrium, and it's all set up with some changes in the concentration of some ions in that hypothalamus and how that it is going to react to increases in temperature on the surface of your body.